All right, so for this video, we're going to talk about exponential functions and our essential understanding, what you will need to know at the end of this video, along with a few other things. But questions that you'll have to answer at the end is growth versus decay. All right, so you'll have to be able to identify whether or not a exponential function is a growth or decay. You'll also have to be able to graph an exponential function as well. All right, so in this chapter, we're going to be dealing with exponential functions, but in this video, it's going to be growth and decay and graphing. So what is an exponential function? Well, an exponential function is written in the form y is equal to a times b raised to the x power. So an exponential function is when you have your independent variable as your exponent, as your power. Since our x is in our power, this graph will grow, or its y value will increase dramatically. It'll increase very, very quickly compared to what the other types of graphs that we have been doing so far. But when we have this exponential function, there's a few restrictions that we have on our a and our b. So a cannot be equal to 0. Because if a is equal to 0, then this entire thing would just be y is equal to 0, because 0 times any number will give us 0. So a cannot be 0, or else we don't have an exponential function, we just have a constant function. The other one, for b, we have a few restrictions. B has to be greater than 0. All right, b cannot be negative. The reason is because in our exponential form, we can substitute any number we want in for x, meaning our domain is all real numbers. So it could be fractions, it could be 1/2, it could be positive, negative, anything. Well, if b were to be able to be a negative number, then we will no longer be able to raise x to the 1/2 power, because we can't take the square root of a negative number and get real solutions. So by restricting our domain of b being greater than 0, it allows, by restricting our b to be greater than 0, it allows for us to have the domain of all real numbers. So we only, for exponential functions, b has to be greater than 0. Also, if b was a negative number, you'll see our graphs for exponential functions will look like this. Well, if b was a negative number, then in our function, if it was, say, -2, well, -2 raised to the first power will be -2, then -2 to the squared will be 4, and then -2 to the third will be -8. So it would not be our exponential function graph that we have. All right, and then the last thing is b cannot be equal to 1. And the reason why b cannot be equal to 1 is because 1 raised to any power is going to be 1. So our graph would once again be a constant if b was to be equal to 1. All right, so that's just basic, talking about the basics of the exponential functions. We will discuss later on in other videos as well a little bit more as to a formula for exponential functions. So the first thing that we're going to do for this is we're going to graph the equation y is equal to 2x. Now we know that this is an exponential function because our x is in the power. Our independent variable is our exponent. So when we are graphing these, remember, you should always visualize what these graphs will look like. A graph will look either like that or like this, right, where it's going to be increasing exponentially. For now, when we graph these, all we're going to do is we're just going to create a table. X and y. All right, our x is our independent variable. So we will do, let's say, -2, -1, 0, 1, and 2, and 3. We'll just plug these in, and then we'll plot these points. All right, so x, when we plug in -2, that becomes 2 to the -2 power, which we know is equal to 1 over 2 squared. So this is 1/4. 2 to the -1 power is equal to 1 over 2 to the first, or 1/2. Anything raised to 0 power we know is 1. 2 to the first power is 2. 2 squared is 4. And 2 cubed is equal to 8. All right, so we have all of these ordered pairs of -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. Now, I knew that my graph ended at 8, so I didn't have anything beyond 3. But we're going to talk about some characteristics of the graph after we graph this. So now let's plot our points. So it would be -2, 1/4, so -2, 1/4, somewhere around there. -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. All right, so now we will draw our graph. Sorry about that. All right. Now, the one thing about this bottom part of this graph, if we kept going to -3, it would be 1 over 2 cubed. -4 is 1 over 2 to the 4th, 1 over 2 to the 5th. Nowhere can this number ever be equal to 0, because even if I did 2 to the -100,000, it's still 1 over 2 to the 100,000. So it will never ever be equal to 0. So if you notice, my graph here never actually crossed over our x-axis, never touches it. It gets incredibly close to it, though. It gets really, really close to it, but it'll never be equal to it. That, where your graph gets really, really close to something and it never actually touches or is equal to it, it's called an asymptote. All right, we'll go over that in a minute. All right, but for now, when we're graphing these, just know it's going to grow exponentially. See here, the rate of change between 0 to 1, it just increases by 1. The rate of change from 1 to 2, it increases by 2. And then the rate of change from 2 to 3, it increased by 4. So our rate of change is increasing dramatically, which is why this graph is growing much quicker than it is in the negative numbers or between 0 and 1. All right, so when you're graphing, just make sure that you're plotting points, or plugging in values for your independent variable, and then plotting the points. All right, so there are two different types of graphs. There is exponential growth and exponential decay. All right, so the exponential growth is what we did before, where as our x values are increasing, our y values are increasing. So as we're moving along in a positive direction for our x, our y values are increasing. If we look at the other graph, this red one here that I'm highlighting in green, as we move along in our x-axis, so positive in our x-axis, our y values are actually all decreasing, and that's exponential decay. All right, so you can just think of them as mirror images of each other, but the exponential growth, as our x is increasing, our y's are increasing. Our exponential decay is as our x are increasing, our y's are decreasing. All right, for exponential growth, as the x value increases, the y increases. For exponential decay, as the x increases, the y decreases or approaches 0. And as we talked about before in the last one, an asymptote. An asymptote is a line that a graph approaches as x or y increases in absolute value. So in this case, as our x is increasing, our y value is approaching that 0. As our x is decreasing, our y is approaching that 0. So we just know when we have an asymptote, it'll never actually be equal to that value, but it will approach and get very, very close to it. All right, now we're going to talk about how you can identify if it's growth or decay. So in both of these cases, our a's have to be greater than 0. All right, and if a is greater than 0 and b is greater than 1, then it represents exponential growth. So if b is greater than 1, so any number greater than 1, then it represents exponential growth. If a is greater than 0 and b is between 0 and 1, because remember, b can never be negative, so if b is between 0 and 1, then it represents exponential decay. So all we're doing is we're looking at the number that's being raised to the power, and we're saying, is that number greater than 1? Yes, then it's exponential growth. If that number is greater or less than 1 and greater than 0, then it's exponential decay. And both of these cases, our a has to be positive. All right, our a has to be positive. So let's just go through two examples of identifying exponential growth or decay. So we look at both of these. Our a's in both are positive, so we know that we can use what we discussed on that last side. 0.95 is what's being raised to the power, and since 0.95 is greater than 0 but less than 1, this is going to be exponential decay because it's less than 1. In this case, we have 0.25, so a is greater than 0, and then our b, the number being raised to the power, is 2, so it's greater than 1, and this will be exponential growth. All right, so that's it for this video. Just being able to graph and then being able to identify the difference between growth and decay. We'll get into a little bit more in the next video. But if it's less than 1, greater than 0, less than 1, then it's decay. If it's greater than 1, it is growth.